Chapter 6, Lesson 3, Part 1. In this lesson we have three concepts. First one, slope of the line. Second one, parallel condition, which depends on the slope. Third one, perpendicular condition, which also depend on the slope. Now, what is the slope of the line? So we have a line, and to know the line we need 2 points at least. So to find any slope of a line we will need 2 points. Each one has the coordinates of x and y. So the slope of the line is using these 2 points such that it is denoted by m equal y2 minus y1, these are the y's of the points, over x2 minus x1, and these are the x's of the points. And of course we have to know that x1 doesn't have to be equal to x2, then the denominator will be 0, and we will talk about it now. We have an example. I wrote it for myself, it's not in the book. I have 4 lines, L1, L2, L3, L4. The first line is passing through the points 2, 5 and negative 3, 5. Now I want to find the slope of this line. So L1, I will find M1, the slope of it. It is just like the rule, y2 minus y1 over x2 minus x1. So y2 is 5, minus y1 is 5, over x2 negative 3, over x1 is 2. So 5 minus 5 is 0, and negative 3 minus 2 is negative 5. And 0 over any value is 0. See that when I draw the line L1 in the same color, green color, I found that this is my line using the points that I have, the coordinates. Now go to M2, which is for L2, the slope of L2. It is y2 minus y1, 2 minus 8, over x2 minus x1, 1 minus negative 3, which is plus 3, is going to be 4, and over in the numerator it is negative 6. Simplify, divide by 2, this is negative 3 over 2. The blue line is this one here. The third one, L3, I will find M3 for L3. I will use y2 minus y1 over x2 minus x1, and then the value is 0. It looks like M1, the same slope if you check it. The last line, y2 minus y1 over x2 minus x1, and here this is different because the denominator is 0, and then negative 5 divided by 0, this is undefined value, and this is the yellow line. In the previous slide we found the slopes of all the 4 lines that are having different colors here. Now what we will talk about is some facts about the slopes. Now when we say M1 equals 0, so M1 is this for the green line, the line that has y2 minus y1 equals 0. Also M3 equals 0, this is the red line. Also y2 minus y1 equals 0, since the same value is subtracted from itself. M2 equal negative 3 over 2, and these are the ordered pairs. M4 is undefined. This is for line L4. It is undefined. We will see why. If y2 minus y1 equals 0, that's what we talked about it in M1 and M3 for the 2 lines L3 and L1. So if y2 minus y1 equals 0, then the slope m equals 0. So the line in this case is parallel to x-axis. See now, the line here, L3, and see L1 are parallel to x-axis. So if the line is parallel to x-axis, so the slope is 0. Or if y2 minus y1 equals 0, then the slope is 0. And we can just see the values of y's for any line. If they are equal, so the slope is 0. Now we come to x. If x2 minus x1 equals 0, We know that the slope rule saying that x2 minus x1 is in the denominator. So if the denominator is 0, then the fraction all is undefined. That's why for the yellow line L4, we see that 6 minus 6 is 0, and that's in the denominator. So any line which has x2 and x1 are equal, then the slope is undefined. And see that this line and other lines that having the same value for x, they are parallel to y-axis, such as L4. The last thing, this is just a note now, we will not use it, but we need to understand it. Saying that if Q is the measure of the positive angle that is a line makes with the positive direction for x-axis, then the slope of the line is equal to tan Q. The slope of the line M equals to tan this angle. But this angle must belong to the interval 0, 180, which is half opened. It's closed from 0 side and open from 180, except 90-degree angle. Parallel condition. This is the second part of the lesson. If we have two lines, so if they are parallel, so they will have the same slope. And if they have the same slope, then they are parallel. This is by symbols. L1 is parallel to L2 if and only if M1 equals M2. Now we will talk about the examples to understand all what we learned. Now in example 6, find the slope of the line passing through A and B. So if I have 2 points, I can find the slope of line AB, which is y2 minus y1 over x2 minus x1. So y2 is 1 minus y1 is 3 over 5, which is x2, minus 2, which is x1. This is negative 2 and this is 3. This is the slope of the line AB. In example 7, we have 3 points ABC. We want to prove that these points belong to the same line. So I will find the slope of the segment BC and the slope of segment AB if they have the same slope. So they are belonging to the same line. So slope of AB is y2 minus y1, 1 minus 3, x2 minus x1, 2 minus 4. That's negative 2 over negative 2 is 1. Slope of BC, 0 minus 1 and 1 minus 2. Thus, this is negative 1 over negative 1, which equals 1. So they have the same slope. Slope of AB and the slope of BC are equal. So then ABC belong to the same line. The last part of the lesson is perpendicular condition. Also, we will need two lines such that these two lines are perpendicular if their slopes product equal negative 1. Means that the product of the slope of first line times the slope of second line equals negative 1. Then these two lines are perpendicular. In symbols, L1 is perpendicular with L2 if and only if M1 equals negative 1 over M2, or the product of M1 and M2 equals negative 1. Also, if the product is negative 1, then the lines are perpendicular, since we have if and only if. In example 8, we use the slope to prove that the triangle ABC is right in B. So to prove that the triangle is right here in B, we need to find the slope of BC and the slope of AB. So if M1 and M2, if their product is -1, means that the two lines are perpendicular. So the slope of AB is y2 minus y1. This is y2 minus this is y1 over x2, which is 10, over minus x1, which is a 3. Now this is 4 plus 1 equals 5, and 10 minus 3 equals 7. Also the slope of BC, we find it y2 minus y1, so this is y2 minus y1 over x2 minus x1, and the answer is 7 over -5. And if we multiply the products, if we multiply the slopes of the first segment and the second segment, slope of AB multiplied by the slope of BC, this is 5 over 7 times 7 over -5, and the product is -1. So the two segments are perpendicular, so the triangle ABC is right in B. Okay, now we come to example 9. In example 9, given to us that the points A, B, C are in a straightness, means that they are on the same line. Find the value of B in R. B belongs to R, is a real number. We want to find its value. It is found here in the ordered pair of A and in the ordered pair of C. So since they are on straightness, means that the slope of AB equal to the slope of BC. So what is the slope of AB? It is y2 minus y1 over x2 minus x1. So this is 2 minus b over -1 minus 0 equal the second slope BC y2, which is b minus 4, minus 2, which is y1, over x2 minus x1 -2 plus 1. Now when we simplify, this is going to be 2 minus b over -1 equal b minus, since we have minus 4 minus 2, this is b minus 6 over, when we say -2 plus 1, the answer is -1. So the denominators are equal, then the numerators is 2 minus b equal b minus 6. So we transfer the negative b here and the -6 to the other side. Negative b, when it comes here, it's going to be positive b, and positive b, they are 2b. 6, when it is transferred to here, it's going to be positive 6. With positive 2, they are 8. So 2b equal 8, divide by by 2 both sides. So the value of b is 4, which is wanted in the example.